Hi, this is Mr. Manley. In this video, I want to talk about functions. What is a function? Now, probably, if you're in a pre-calculus class, you have some idea about what a function is. And it's very important to have some perspective on what a function is because it's going to keep coming up, certainly through the rest of a pre-calculus curriculum and into a calculus curriculum as well. For most students, I think when they see the word function, they just associate that with equation. And that's fine, but it's not just that it's a substitute for the word equation. One thing that I want to talk about is about the function as a relation. It's a relationship between two variables, let's say. And we use the word variables. That's a mathematic word, but we could say a relationship between two things. And it's a special relationship because I can have an equation. I can have like a y equals x equation. Like I can have an equation like this. X squared plus y squared equals 4. And that is an equation. That is an equation. Yes. It is a relationship. Yes. But it is not a function. And that's fine. There are equations, there are relations that are significant, but they are not functions. I'm not so much concerned about the difference in this discussion between a relation and a function. What I'm more interested in discussing is this idea of what is a function. And it's this relationship. And yes, it is a special relationship between two variables. But I'm not going to worry about the special nature of the relationship. I just want to talk about the relationship between two variables. The idea is that we observe our world. And we look at the world and we try to make sense of it. We try to find patterns. And one simple way, an entry-level way to find a pattern is to look for a relationship between two things. If I look at this picture here, I'm seeing a couple of things. One, like right in the graph, I've got down here are the months of the year, and along here is a percent change in the stock market. So there's a relationship, or we're looking for a relationship at least, between time, what month of the year is it, and the stock market. What percent is it going up or going down? There's also another kind of hidden relationship in here, or relationship that is, we could infer is being addressed, which is the relationship between time, the percent change in the stock market, and the COVID-19 virus. So here's a situation where we're using functions to examine an economic relationship. And it has to do with two variables, time and, let's say, money. Here's another relationship. It is Kepler's third law. Kepler's third law examines the relationship between distance, it's going to be distance from the sun, and time to orbit the sun. And there's a relationship here. This previous relationship here was in economics. You might notice that relationship is a little bit, shall we say, unpredictable. The relationships that we find in science, as in Kepler's third law, are predictable. And if we looked at this relationship, off the top of my head, I can't, I believe it's an exponential relationship, but don't hold me to that. But let's just say, for instance, that it is, then that would be a smooth curve. There would be no unpredictability in the curve in this scientific use of function. There's a relationship, a special relationship, and it is very predictive of what is going to happen when I vary one variable, when I change one variable, like distance, and observe what that does to time. So again, it's back to this relationship between two variables. Here it's distance and time. Back here it was money and time. And also we have these areas in which the function is being applied. Economics, and then science. Here, I'm thinking about a social relationship. Thinking about people and how people related to each other or how people behave. Perhaps I could come up with a relationship. I mean, you just stop and think for a moment. Could you think of a relationship between two things? That could be a functional relationship. I'll make one up here. I'll say that I wonder if there's a relationship between, say, friendship and blood pressure. Just making that up off the top of my head. But you get the idea that there could be some functional relationship where the number of friendships that a person has is predictive of what their blood pressure would be. Now, this one most likely would not be a very smooth relationship, but we might be able to, maybe it's possible to gather enough information that we get some sort of relationship and maybe some sort of curve could go with that relationship, and we would be able to find a function that fits that curve. So in review, we have function is a relationship. It's a relationship between at least two things, and we have these various arenas in which functions can be applied. The final thing I want to talk about is the relationship, the way we talk about the relationship between these two things. We say the most basic, the instructional point or the instructional entry into the function is when we say y is a function of x. That's another way of saying y depends on x. Y is a function of x, y depends on x. And when we have that relationship, when we say it like that, what we're expecting is, we're expecting an equation where y is equal to some expression in terms of x. And I'm just going to use this little notation there. I don't know if any other mathematician or teacher uses that, but I use that to represent it, some expression in terms of x. And it could be any sort of expression. It could be an expression x squared plus 3x minus 7. So it could be what would be a quadratic expression, or it could be a radical expression, so that we could have a function that uses radicals and the variable x. We could have an expression that uses trigonometry. So I could have sine of 2x plus 3. So I have a trigonometric expression. Could be a function. And y is a function of that trigonometric expression. So this is, but the important thing is that we're saying y is a function of x, y depends on x. And then let's just take that, and just to wrap up here, let's apply that to what we saw with the previous ones. What are we able to say? We are able to say, with the economic one, we would say that, I could say that money is a function of time. All right, and the way that money was coming out was a percent change in the stock market, and time was coming out as what month of the year was it. And then we could say that, what was the next one? Time to orbit the sun is a function of distance, of the distance from the sun. And then for the last one, we were saying that blood pressure, a person's blood pressure is a function of friends, how many friends they have. All right, and all of these could find their way, and then what we'd want to do is we want to be able to collect the data that could give us the information so that we could say what's the equation, and say that money is equal to something, some equation, an expression in terms of time, and we could say that time is equal to something in terms of distance for Kepler's law, and we could say that blood pressure is equal to something in terms of the number of friends. Okay, so that's more. I'm trying to give you a little bit more of a perspective on what is it that we mean when we say this word function. And yes, at the very root of it, we mean equation. But going a little bit deeper, it's about relationship. And going even a little bit deeper, it's about a relationship where we can determine that something depends on something else.